Good morning, guys. Myself Shridhar, working as assistant professor in the Department of Electronics and Communication at Government Engineering College, Haveri. Today we are just going for your basic electronics subject. In that module 1, semiconductor diodes and application. In this module 1, so we are just going for the session 6, that is of a capacitor filters. Okay, so in this we are just going for the filters and what are this capacitor means. Already people have come across the previous session, half wave rectifier, full wave rectifier. So if we just connect a capacitor across it, so what will be the thing? We are just going for that one. Okay, first, what is this filter? A filter is a circuit capable of passing or amplifying certain frequencies while attenuating other frequencies. Okay, so we are just passing amplifying certain frequencies while attenuating our other frequencies. A filter can extract important frequencies from signal that also contain undesirable or irrelevant frequencies. If we want to remove the unwanted or undesirable or irrelevant frequencies, we will be going for this filter. Filter can be placed in one of two categories, that is passive or active. So depending upon what kind of components is being used, so we will be differentiating it as a passive or a active. Passive filters include only passive components such as resistor, capacitors and inductors, and the active filters use active components such as op amps in addition to resistors and capacitors, but not inductors. That is, in passive we will be using resistors, capacitors and inductors, but in active along with the op amp we use resistors and capacitors, but will not be using the inductors. Next, why we require filter, or what is the need of filter? The filter is an electronic device that allow passing the DC component of the load and blocks the AC component of the rectifier output. So what does it do? It blocks the AC component of the rectifier output by passing the DC component of the load. Thus, the output of the filter circuit will be steady DC voltage. Okay, so what it is, the why we require the filter is it blocks the AC component by passing the DC component of the load and will be getting a steady DC voltage. The half wave rectifier converts the alternating into AC current into a direct current DC, but the direct current, or the whatever the obtained direct current at the output is not a pure direct current, it is a pulsating direct current. So normal, if you going for a half wave rectifier without the filter, that means whatever the DC component whatever we are getting, it is not of a purest form. So what are the problems facing is with the fluctuating DC current is, so we require the filter to remove all of the AC component whatever the extra activity will be there. Next, introduction of a capacitor filter. A capacitor input filter is a filter circuit in which the first element of the capacitor connected in parallel with the output of the rectifier in a linear power supply. See here, the capacitor is being placed parallel to the the voltage source. A capacitor filter in which the first element of capacitor connected in parallel with the output of the rectifier in the linear power supply. Capacitor is placed in parallel with the linear power supply. Next, the capacitor increases the DC voltage and decreases the ripple voltage components of the output. At the output, DC voltage decreases the ripple voltage. The capacitor is often referred to as a smoothing capacitor or reservoir capacitor. So where the filters are used for smoothing of the thing. The capacitor is often followed by other alternating series and parallel filter elements to further reduce ripple voltage or adjust the DC voltage. So along with the capacitor, we require other filtering elements. Okay, so these are some of the thing. A filter is made up of a combination of components such as capacitor, resistors and inductor, as we previously mentioned. The capacitor allows the AC component blocks the DC component, that is X is equal to 1 divided by 2 pi Fc, and for DC F is equal to 0, hence X is equal to infinity, and for AC for small frequency we will get some XC value. For DC the frequency is equal to 0, so obviously the XC will be of infinite. So here see here, so we are just connecting a half wave rectifier with the C filter. C filter means the capacitor filter. So this one, so AC input signal, so this one is a transformer, okay. So diode you have been required, as well as a load resistance for a half wave rectifier. What we are doing is we are just connecting a parallel capacitor along with the load resistor RL. Okay, so this one is the AC input and this one is the DC output. So normally when you are doing passing through the half wave rectifier, for waveform, what we are getting is just the sine wave for only for the positive half cycle, and for the negative half cycle it was off, and once again we are getting this. By placing a capacitor we are just getting the peak voltages. See here, just getting the peak voltages from the only for the positive half cycles, okay, not for the negative half cycle. For negative half cycle it is just a reduced line, okay. See, so this one is the what the capacitor means, we are just getting the peak to peak voltage, okay. See, for half charging of the capacitor means a normal component, how it will be just working as a component high frequency for charging as well as the discharging. So during what it is having, during positive half cycle the capacitor is charged, okay. During the negative half cycle when it is, so it is at the point discharging point, at once again the during the positive half cycle it is charged. However, with positive half cycle, so this one is the exact output waveform. So this one is a half wave rectifier, input is the sine wave. So what, so half wave rectifier means during the positive half cycle we will be getting the output that across the load current RL, okay. See, during the negative half cycle it is off state. Once again, see the capacitor at this point it is charging, and once again at this charging until the next positive half cycle, and once again it has been continuously going on, and this one is across the voltage across the time, okay. So what are the problems with half wave rectifier with C filter is, so the power loss will be there as well as maximum number of ripples will be having, okay. So what are the factors, or what are the formula for the ripple factor, that gamma is equal to 1 divided by 2 into root 3 Fc into RL. So this one is the formula for the ripple factor for the capacitor C filter, and DC output voltage of half wave filter is VDC is equal to Vm minus Vr by 2. Therefore VDC is equal to Vm divided by 1 plus 1 divided by 2 Fc into RL. Next, center tap full wave rectifier with C filter. So it is also the same as if it is working for your full wave rectifier. We are just placing a capacitor across the load resistor RL. So this one is a center tapped transformer. So two diodes D1 and D2. D1 will be active during the forward voltage, positive voltage, and D2 will be in D2 will be forward bias during the negative half cycle, okay. So this one is a DC output, okay, only the peak to peak, that is during the charging as well as the discharging of the capacitor will be getting this one, okay. See, charging as well as discharging during the negative cycle also will be having. So the curves whatever you will be getting only will be taking of the peak to peak voltage, okay. So this one is the formula for the same thing, gamma is equal to 1 by 2 for output of the full wave rectifier it is, and formula for VDC, that is the filter DC output voltage, is given by Vm divided by 1 plus 1 divided by 4 Fc into RL. So we are just going for one of the problem. In a center tap full wave rectifier, the forward resistance of the diode is 10 ohm, the load resistance is 2 kilo ohm, the voltage across half the secondary winding is 220 volts. Calculate the ripple factor and efficiency of rectification. If a capacitor value of 25 microfarad is connected across the load, what is the modified ripple factor? Solution. So what are the given values here? Given is equal to forward resistance Rf is equal to what? 10 ohm, V2 is equal to 220 volts, that is the secondary winding is 220 volts. RL is equal to what? 2 kilo ohm, that is the load resistance they are given. V2, the second voltage is given it as 220 volts, and the RF voltage is given it as, that is the forward resistance is given it as 10 ohm, as well as the capacitance value is given it as 25 microfarad. So the peak in value of the second voltage Vm is equal to root 2 into V2. So we will be getting the root 2 into V2, the value is 220. So if you calculate, we will be getting it as 31, or that is 311 volts. Peak value of load current Im is equal to Vm divided by Rf plus RL. 311 divided by 10 plus 2000 is equal to 155 milliamps, and the RMS value of the load current IRMS is equal to Im by root 2, that is 155 divided by root 2 is equal to 11 milliamps, and the DC load current, it is given by IDC is equal to 2 Im by pi. So 2 into Im value calculated as 155 divided by pi is 98 milliamps. So these are all the factors what you should be calculating to get the ripple, to calculate the ripple factor gamma. So the ripple factor gamma is equal to square root of IRMS by IDC whole square minus 1. So square root of 11 square divided by 98 square minus 1 is will be getting it as 0.51, and the rectification efficiency gamma is equal to PDC by PAC, that is I square DC into RL divided by I square RMS into RF plus RL. So if we calculate it, we will be getting it as 0.78 or 78.9%, because the efficiency will be always calculated in percentage. And if a capacitor value of 25 microfarad is connected across the load, the modified ripple factor is, the formula is gamma is equal to 1 divided by 4 into root 3 FC into RL. If we put the values, F value, C value, as well as the load resistance RL value, we will be getting the value it as 0.057. So in this fashion, so we can just calculate by remembering the formulas. Okay, next is choke filter. Choke filter consists of an inductor connected in series with rectifier output circuit and a capacitor connected in parallel with a load resistor. Okay, in normal, so we're just connecting a capacitor across the load resistor RL, but in a choke filter we are just connecting one inductor, that is this one, at this part is in series with the rectifier output. It is also called L section filter because the inductor and capacitors are connected in the shape of inverted L shape as well as the inverted L shape. So it is known as the L section filter. The output pulsating DC voltage from a rectifier circuit passes through the inductor or choke coil. The output pulsating DC voltage from a rectifier circuit passes through the inductor or a choke coil. The inductor has low DC resistance and extremely high AC resistance or reactance. Okay, sorry. Thus, ripples get filtered through choke coil. Why is you requiring choke coil means to remove the ripples. Okay. So next, the working of a choke filter or a section filter. When the present DC from the output of a rectifier circuit is fed into a choke filter, the AC ripples present in the output DC voltage gets filtered by choke coil. See here. So what are the choke will been reduced now. Okay. Next, the inductor has the property to block AC and pass DC. This is because DC resistance of inductor is low and AC impedance of inductor coil is high. Thus AC ripple get blocked by inductor coil. So this one is the normal sine wave what you will be getting at the full wave rectifier without filter and with the choke filter. What it was happening with the capacitor filter was we were getting a spikes. Now it is been reduced. The peaks have been reduced. See here. So this one is known as the with choke filter, and this is the formula, that is omega t, and VDC is equal to 2 by pi into VL max, and this is the load voltage, and this one is the max. So next is the peak rectifier. So this is also a peak rectifier, produces an output that follows an peak of the input voltage. Peak rectifier stores the peak value of input voltage for infinite time duration until it comes to reset condition. So we are just considering the peak rectifier, we are just considering diode, only the peak value it is been taken by. Okay, so this one is just a half a rectifier, as we know that during the negative half will be varying, and this one you are just consider a triangular wave. See the peak value, it is only been considered with the what is the peak voltage getting. See the peak voltage is been just taken. So in the next slide we will be getting peak rectifier and the diode current. So only the peak to peak value it will just be taken. It is just like a capacitor filter, and the reduced also it is been constant for this thing. So this one is your peak rectifier voltage as well as the diode current. It is like your peak detector. Okay, so this completes your section 6, that is of a capacitor filter, and next session we are just going for the applications of diode. Okay, thank you.